Okay, so last time we talked about the how changes in the objective coefficient values and the right-hand side values of each constraint affect the current optimal solution. So now I'm going to summarize what we've done last time and then move on to the new material. So talking about the dual price. Okay, so according to the Lindo, the objective coefficient ranges indicates by this amount, the objective coefficient can be changed without causing a change in the basis. So these are the ranges for the optimality, basically. So the allowable range to stay optimal for the objective coefficient of x1 variable, for example, can be interpreted like this. So the C1 value must be greater than or equal to 3. That's the current coefficient value, which is 3, right? Minus 3. That is the allowable decrease amount, okay? But the C1 must be less than or equal to 3 again from the current value plus 4.5. That's from the allowable increase limit, right? So as a result, the C1 has to be within these ranges. Okay. So we may say that within this range, the current optimal solution remains optimal. Okay. So in other words, within this range, the window glass has to produce 2 doors, 2 glass doors, and 6 windows, right? And graphically, we have shown that if all other parameters remain unchanged, then within this range, the current optimal solution, excuse me, so within this range, the current optimal solution remains optimal. Excuse me. Okay. Sorry, it's really dry. So if the objective coefficient changes, goes beyond the allowable range. So for example, if the slope of the isovalue line becomes steeper than the one in the plant number 3 constraint, then the optimal point needs to be relocated to point B, to point A, I'm sorry, right? So, of course, at point A, the isovalue line intersecting the feasible reason, right? So in this case, the basis has been changed, right? The old optimal point, which is B, the basis is right there, right? But right now, at the new optimal point A, the basis has different, right? So we may say that if the objective coefficient change goes beyond the allowable range, then the basis will be changed. Okay. Okay. And in Lindo output, the right-hand side ranges for each row are the amount by which the right-hand side can be varied, while the current optimal solution remains feasible. So this range is about the feasibility. Okay. So here, for example, the allowable range to stay feasible for the right-hand side of the last constraint can be interpreted like this. So B3 must be greater than or equal to 18. It's from the current range, current right-hand side value, right? Minus 6. That is the allowable decrease limit, right? And the B3 must be less than equal to 18, again, the current right-hand side value, plus 6, which is from here, allowable increase limit, right? So as a result, within this range, the current optimal solution remains feasible, okay? And graphically, this line represents the third constraint, right? And the right-hand side value of the third constraints can vary within these ranges, right? All the way up to here. So these are the ranges, right? While the current optimal solution remains feasible. Oh, I'm sorry. Okay. And of course, if the change in the right-hand side value goes beyond the allowable range, for example, if B3 is decreased to it's 10, I believe, then the plant number 2 and number 3 constraints are binding at the infeasible point, right? This is the feasible reason. So here, plan number 2 and plan number 3 constraints are binding at the infeasible reason, right? So the current basis is no longer be feasible. Okay. Okay, now let's talk about dual price. What is dual price? First of all, I want you to recall your memory. A couple of weeks ago, you've learned how to interpret dual variable economically, right? So the dual variable represents the rate of change of the optimal objective value with respect to the right-hand side values, okay? And the dual variable is also known as simplex multiplier, which is represented by pi sometimes. But anyhow, now we are interested in what is called dual price, okay? So Lindo provides the dual price for each constraint, okay? And according to the Lindo, the dual price represents the amount by which the objective function value would be improved given a unit of increase in the right-hand side values of the constraint. Okay. Of course, here the improved means the increase in a maximization problem, right? But improved means decrease in the minimization problem. So from these two, what I can tell you is in the maximization problem, the dual price has the same meaning as dual variable. Is that right? But in the minimization problem, the dual price is going to be negative value of dual variable because of this word improved. Does that make sense? And the dual price are sometimes called shadow price. Okay. And they tell us how much we should be willing to pay for additional units of resources. Usually that's the right-hand side values of the resource constraint, right? Okay, so here from Lindo, we've got 0, 1.5, and 1 for the dual prices of each constraint, right? Right here. So this tells us if the right-hand side value of the last constraint, for example, is increased from 18 to, let's say, 19, okay? Then the objective function value becomes 37. In other words, if plan number 3 is available for 19 hours per week instead of 18 hours per week, then the total weekly profit would be increased to $37, or maybe we can say 37K from 36K. Because the objective function value will be improved, increased in the maximization problem by this much. Does that make sense? Now, what if the right-hand side value of the last constraints is decreased from 18 to, let's say, 17? Then what's going to happen? The objective function value will decrease to 35, okay, right? However, one very important thing, this dual price is valid only if the corresponding right-hand side value changes within the allowable ranges, okay? This is quite important, so keep in mind that. So for example, considering the value of 1 as a dual price for the last constraint, this value remains valid only if the right-hand side value of the last constraint changes within these ranges, okay? So if the change in the right-hand side value goes beyond this allowable range, then the dual price of 1 here doesn't mean anything, okay? It doesn't mean anything. So we may also say that within these ranges, okay, within these right-hand side ranges, the current dual price remains valid, okay? So please keep in mind that. Okay, so like we did last time, here, let's say B3 is the available production time at plant number 3. Okay, so the current value of B3 is how much? 18. Now we will see the factor of change in the value of B3 on the optimal, on the current optimal objective function value. Okay, so if we increase the right-hand side value of B3 by 1, which means if B3 is increased to 19, what's going to happen? The objective function value will be improved. So it's going to be increased by this much. Is that right? So the objective function value becomes 36 plus 1 times 1. So the first one is the increased amount, right? And the second value of 1 is the dual price. Okay? So it's going to be 37. That's going to be the new objective function value. Okay? Graphically, the changing in the B3 shifts the plant number 3 constraints parallel to its current position, right? So the new optimal solution occurs right here. With the corresponding objective function value of 37, with the improvement of 1, right? Of course, the new optimal point, both plant number 2 and plant number 3 constraints are still binding in the feasible region, right? So in this case, okay. Okay, now let's suppose if B3 is increased by 6. So if it becomes 24, what's going to happen? So in this case, the increment of 6 is still within the allowable increase limit, which is 6, right? So we may say that the objective function value will be improved by 6 times this much. So the objective function value becomes 36 plus 6 times 1. So that's the increment times 1, right? That's going to be from the dual price. As a result, the objective function value becomes 42. So graphically, the new optimal solution occurs right here, right? With the corresponding new optimal objective function value of 42 with the improvement of 6, right? Now, what if the B3 is increased by 9 units, which goes beyond the allowable increase limit? Can we still say that the objective function value is improved by 9 times this much? So what I mean is, new objective function value will be 9 times 1. So that is going to be 45. So if the original optimal point is visible, then we can answer yes. However, as you can see here, in this case, the original optimal point is no longer be feasible. Right? Because in this case, plan number 2, plan number 3 constraints are binding at an infeasible point, right? Because in this case, plan number 1 constraint for doors is not satisfied. Okay. And because the dual price becomes valid only if the current optimal solution remains feasible. In this case, we cannot use the information about the dual price anymore. So I'd say we don't have enough information to answer that question or something like that. Okay. Now, if we if the what if B3 is decreased by 1 unit, which is still within the allowable range, what happened to the objective function value then? Of course, the objective function value will be decreased by 1 times this much, right? So the objective function value will be changed to 36 minus 1 times 1. So that's the amount of changes, and this one is from the dual price. As a result, our objective function value will be decreased to 35. Okay. So graphically, again, changing in the B3 will move the plant number 3 constraints parallel to its current position, right? So the new optimal point is right here with the objective function value of 35. Okay. Again, at this point, both plan number 2, number 3 constraints are binding in the feasible region. Okay, that's the important thing. Okay, now what if B3 is decreased by 6 units, which is still within the allowable decrease limit? Then the objective function value will be decreased by 6 times this much, right? So in that case, it's going to be 36 minus 6 times 1, which becomes 30, right? The new optimal point is right here, with value of 30, right? Now, what if B3 is decreased by 8 units, which goes beyond the allowable decrease limit? Can we still say the objective function value is decreased by 8 times this much? No. That's because the original optimal solution is no longer be feasible, right? The plan number 2 and plan number 3 constraints are binding at an infeasible point, having x1 value has negative value, right? So you remember the dual price is valid only if the current optimal solution remains feasible. So in this case, the dual price is no longer valid. So again, I have to say we cannot answer that question because we don't have enough information. Okay. Okay, so in summary, the dual price is valid only if the corresponding right-hand side values is changes within the allowable ranges. Okay. So for example, okay, for the dual price of 1 for the last constraints, this value of 1 is valid only if the right-hand side value of the last constraint changes within this allowable range. So graphically, the dual price for the last constraint, third constraint, is valid only within these ranges of the right-hand side values. Okay, I believe this is all for today. Based on what we've discussed during the last time and today, we're gonna solve several different example problems from now on. So next time, I'm gonna give you a couple of example problems, okay, for the sensitivity analysis. Okay, thank you very much. I will see you next time. Bye-bye.